Okay, what we have to look at next is power. And power in day-to-day speak, we sometimes use wrongly. We kind of talk about something that's powerful, we think of as being it produces a big force, and that's not what power is in physics, okay? Power is a measure of how quickly energy is transferred. In fact, it's the amount of energy that is transferred in 1 second. So we have an example here that if you have a 30-watt speaker, okay, and when you're buying speakers or like a Bluetooth speaker or something like that, what you should look at, amongst other things, is the power of it. So if I have a little speaker and it tells me that the power is 30 watts, if it's 100% efficient, what that means is that it will produce 30 joules of sound every second. Okay, which means if I was to leave this on for say 10 seconds, well, if it's producing 30 joules of sound every second, that would mean the total energy of a sound energy produced would be 300 joules. Okay, or another example here is, let's say we have a motor, okay, so a little electric motor, and it transfers, so say we're using the motor to lift something up like a little crane, you'll see that in our future experiment, but let's say it does 400 joules of work in 4 seconds, sorry, 200 joules in 4 seconds. Well, we could say, well, its power output is 200 joules in 4 seconds, but really it's easier to compare everything fairly. So what we do is we would say how much energy it's transferred in 1 second. So we divide the 200 by 4 and say that that is 50 watts. So our equation for power is that it is the energy transferred divided by the time. Okay, so power is the work done divided by time. Okay, and our work done is the energy transferred, if you remember. So because it's the energy transferred, it's measured in joules. Time, as always in physics, should be measured in seconds. And the power then we have to be very careful with, because it's measured in watts, which is W, joules, J, seconds, S. So work done is denoted by the letter W, but measured in joules, letter J. Power is denoted by the letter P, but measured in watts, W. Okay, so you can see how this can get a little bit confusing. Let's look at 2 examples here. So it says an 80-kilogram man can lift himself 5 meters up a rope in 10 seconds. So we have our person who's climbing up a rope, and it is 5 meters in 10 seconds. It takes time of 10 seconds, 5 meters, and this person is 80 kilograms. And we're trying to work out their power. Now, if I was asked this in an exam, I would think power equals work done divided by time. Do I know the time? Yep. Do I know the work done? No. But can I work it out? Well, our equation for work done is that it is force times distance. Do I have a distance? Yep, 5 meters. Do I have a force? No, because 80 kilograms isn't a force. Can I work out the force needed to lift an 80-kilogram man up a rope? Yep. Because it's a weight, okay, which is mass times gravity. So the first thing we do here is we work out that on Earth, because gravity is 10, to lift an 80-kilogram person up a rope, it will require a force of 800 newtons. Once we've done that, we can put this in for our force, okay? So the work done, the energy transferred in that person lifting themselves up that 5 meters is 800 times 5, which is 4,000 joules. And they do that in 10 seconds, so we can then put this into this equation here, and it gives us power is work done divided by time. Power is 4,000 divided by time, 10, so the power is 400 watts. Okay? So you can see there, sometimes we have to use other equations to work out the inputs for our power equation, and quite often we're using the work done equals force times distance. Next one says, I know it's written here, but we'll just do it at the side as well, go through it step by step. If a car engine has a power of 2 kilowatts, Now, as soon as I see that, I think the same thing I do with kilometers. I multiply it by 1,000 to get that into watts. How long will it take? So we're looking to find the time to transfer an energy. Now, a lot of people then write down E for energy, but energy transferred from one type to another is the work done, W. And it's 5 kilojoules, which is 5,000 joules. Once we've worked that out, we then put in our equation, power equals work done divided by time. Power we worked out was 2,000 is equal to the work done, 5,000 divided by T. Multiply both sides by T, and then divide both sides by 2,000. Which gives us 2.5 seconds. Okay? So what I want you to do now is to try these questions, and I'll post a little video with the solutions at the end of them. Okay?